The general goal of capstones is to let the students apply their skills. This is the Robotics Capstone. The goal is to have students apply their skills on a robotics project. So the students program a robot, which is a mobile manipulator called PR2, and they basically program it to do useful things like picking stuff off the floor or delivering mail around the building, etc. Even though most of them didn't have any background in robotics, they very fastly learned to use the existing tools. Basically, the way that I structured the class, for the first month, the students just learned about the actuators. So they learned how to make the robot move forward, move its arms to preset positions, or move its head around. And the students built teleoperation interfaces where, through a screen interface, make the robot do different kinds of things. From there on, we moved to perception, where the robot needs to see what's in the environment and make decisions on its own on what to do. And basically for that part, the students chose their own projects, and we talked to them about what was possible and how some of the problems could be made easier.
The problem is every time I update the goal, the robot comes to a stop, makes a new plan, starts moving again.
Maybe going to the marker at that point will unstuck it.
Okay.
Part of the process was to storyboard what the final demonstration was going to be. So basically students think through the scenarios of how someone would interact with the robot, what the robot would do as part of a demonstration of the system. In robotics, it's easy to make things, but it's very hard to get them to work. These guys are doing librarian robot. So the idea is that you would go to the library, and the librarian is a robot, and you can request a book, and it has an inventory of the books and can bring you the right book.
Learned a lot about the robotic operating system, and being able to work with your team and develop a project from the ground up is pretty cool.
But also you can return a book, and there are some markers on the books that are unique identifiers.
I started out doing linguistics. And then I found out about computational linguistics and natural language processing, combination of linguistics and computer science. So I was like, oh, that sounds like two things that I love. I was finishing up my linguistics coursework here at UW, and I started taking computer science, and really sort of fell in love with it again, like I did when I was young.
Thank you.
One thing that worked really successfully with our demo was speech recognition.
It was published in 2004.
That was our last hurdle to get over. And speech recognition is just kind of complicated because to human beings it's intuitive, whereas to robots you have to actually teach it the words it needs to understand. Another success I think was the way we figured out how to place books on the shelf. So she kind of grabs the book and lowers it gently onto the shelf instead of just like dropping it from midair. And computer science teaches you basic logic and problem solving skills.
You know, maybe you're feeling a little lonely, a little depressed, you don't have any friends, you know, your family's so far away, but you do happen to have $400,000 Rosie robot. Well, so now you can play tic-tac-toe with Rosie.
Your turn.
Your turn?
Yeah.
On this project, there was a couple of things that were kind of hard. One of them was perception, figuring out what is a game piece, what's the current state of the board given the pieces on the board, whose turn is it. There's also manipulation. How can you put them back down? How can you not knock over the entire stack when you pick up a piece?
Thanks for playing. You have the right to remain silent.
Our project goal was to basically design a robot initially that could be used to apprehend suspects that would follow it, run after them, capture them. But we thought also a more like follow people around and carry objects for them. So we wanted to design and implement a way for a robot to follow a marker, and then after that traverse an unknown surrounding.
I think when we were making our final decisions was right around the time we started navigation. It seemed like a really cool application of different things like finding a marker, getting its position, convincing the robot to actually navigate to it, and then eventually interacting with the person outside of the standard navigation.
And just fine-tuning all the sensor parameters so it actually goes through some kind of random or unknown environment quickly was probably the most difficult thing in this project.
It's a very rewarding thing to be able to write some code and just run it and have it work. So things like, you know, we hold the marker up and the head's going to follow it. It's really cool to see that and be just like, oh, I typed a bunch of characters and all of a sudden, you know, now it's following a marker. So I definitely think that's one of the things just computer science in general has over a lot of other majors is just how quickly you can do things and get results.